Hello everyone, my name is Kiran Mampilly. I am doing this video on behalf of my group members Mili, Gupta and Ruchika Sharma. This video actually explains about a use case which we actually did as part of our big data analysis project. So let me talk more about the project before we get into the actual hands-on analysis. So as you can see, we did a project on Bitcoin Alpha Trust Network. So as you all know, Bitcoin is a digital cryptocurrency, and because of its nature, there are many problems with it in the sense that you need to actually know a trustworthy person in the online space to actually buy Bitcoins from. So to make that kind of decisions, it's not always easy. And through this data analysis, we have actually found out some of the most trustworthy users in the online space which actually deal with Bitcoins. So there's actually a research conducted. The data sets were available online at the Stanford data repository. So we just took it and we did it, the data analysis by our own. The whole point of this video is that you would get to know how to analyze data like these hands-on. So let me get to it right away. First is the introduction. As you see, the data we collected has nodes and edges, which is a list of actors, and the edges being the list of relations. Think of it this way: there are two actors, A and B. Now A would comment about B in a sense that A is actually the rater and B is the ratee. So A would have purchased Bitcoins from B, and after the purchase, A would have rated how good was B, how trustworthy was B. So that's how the data is actually made, and it's that data which we are analyzing in Gephi. I'll come to the data soon. So as you can see, there are 3,783 nodes, edges 24,186. You might see a slight variation in this because some of the duplicates were taken out of the set and some self loops were taken out of the set. While cleaning process, we lost some. The range of edge weight is -10 to 10, this which we have actually made from 0 to 10 through Excel. So yeah, I'll come on to the main data. This is the literature review. The theoretical ways is centrality, eigenvector, reciprocity, modularity, average weighted degree, network degree, graph density, all those things I expect everyone to know. But if you have any doubts on this, please do refer to the PPT which we have actually made. We have actually uploaded it to Scribble. So let's go on to the data. Now, once we open the data, this is what we get. So this is actually the initial data which we get. As you can see, this is a source, this is a target, this is a weight, and this is the time. So this time is actually it's actually a different format. The format being this time is actually the number of seconds from 1970. There's a particular name for this time, which I'm forgetting right now, but if we do time series analysis, we actually need to convert this time. So this is the data which we actually get, and before actually proceeding with this data, there's some changes which we have to make. The first change being Gephi doesn't recognize timestamps in this format. So in order to convert the time from this to the format which Gephi does, we have to use this equation which is displayed over here. The cell being the cell reference. Let me show you a slide example. So let's make this as 1 and 1970. Okay, so this is January 1st 1970. Let me just add over there, and over here what I would like to do is, this is the number of seconds from January 1st 1970. So which we actually take this and we divide it by 60, which is the number of seconds in a minute, into again 60, or 60 minutes make an hour, into 24 hours make a day. So which we actually do it, we get 15853.17, and over here you just add these two formats, bam, you get the actual date. So this is actually the date in which this response was actually filed. Now this again is in a different format. You could just go to the format cells option and actually change this to year, month, day, which is actually the format which Gephi recognizes. So after doing this type of cleaning, the second thing what you have to do is that you have to give column headings over there, so Gephi would easily recognize your data. So here you just insert a column and you have to put source, target, this would be the weights, and this would be the time. Now again, coming to the weights, as you can see, the weights is between -10 to 10. So we actually need to make that into, as you can see here, there are negative data. We actually need to make that into positive values, as in from in between 0 to 10. So Excel lets you do that pretty easy, so I'm not going into that. So let's come on to the actual data. So I'm actually opening Gephi over here. As you can see, we have opened Gephi. Now we are going to file, import spreadsheet. Now from import spreadsheet, you have to actually take the data. So this is the data which I downloaded from net. This is the clear data, the data with the headings and everything. So that's the main data. I open it. And as you can see, Gephi automatically detects the source, target, weight, as in, although we have given the headings, it automatically does that. And you can see I have cleared the negative values, as in I have converted the -10 to 10 to 0 to 10. So I have done that. You go to the next step. As you can see, Gephi again automatically detected the weights. Now let's click on finish. Yeah. So these are the nodes, these are the edges. And it's a directed connection, and as you can see, the weights over here, it has actually come over here. Now you actually go to the overview part. In overview part, you could actually see, so once you take the first look, it's actually like a dense matter over here. Now there are a number of things which we actually need to do over here so that it becomes easy for us to read many variables and things of that sort. So the first thing what you have to do is that you have to actually click on this rain gold layout. So we have to make that run. Before that, let's do a force atlas. We'll do a force atlas, and over here gravity. So that's the attraction between the nodes. Let me just reduce that. Let me just put that as 3, and that the speed of the whole force atlas being happening. Let me make that as 1000. Repulsion strength, I'll make it as again 1000. That's it. Let's click on run. So as you can see, since this is a very data heavy file, it would take some time for actually doing this. But as you can see, the screen has started to expand. The nodes and the edges have started to expand itself. Let me give you a better picture. Yeah, I have minimized the edge font right now, as in the font for the line. So you could much clearly see how the data is being expanded. So I'm hoping this would take some time, but no worries, I have actually made another data so that we could get on with the analysis fast. So yeah, actually see, I have actually clicked on stop, and see, this is the points we get. It's much scattered and it's easy to actually comprehend. Now in this thing, I'll open the data which I have already worked on, but let me just say how we actually do all the statistics. So it's pretty easy, from average degree to everything. Everything is explained in the slide, so if you have any doubts, you could refer to it. You just run all the statistics one by one. So we have got the average degree as 6.393, the weighted degree as 14.538. The network diameter, the network diameter takes itself some time. We'll do the graph density, the hits, modularity, page rank, connected components, and everything. So you could actually get the whole data. So this would just take about a second to finish. Yeah, so we know the network diameter, we have the graph density, hits, modularity, page rank, connected components. So I'm not running all of them. Let me just open the data which I have already worked on, so you get a better idea. Bam. So this is the data which I have actually worked on. If you can actually see, I have used the rain gold layout to its full potential, so it's very much scattered. And I've actually used the labels. I have actually made it a little small so that you know the interpretation which I need, I could make it. So as you can see, the average degree, average weighted degree, the network diameter, graph density, modularity, page rank, connected components, and all of these things are done. Now to visually analyze all of this, the question about our research is actually trying to figure out the most trustworthy users in the Bitcoin environment. So if you go to the data laboratory, you can actually see here the source, the target, the type ID, and the weight. That's for the edges, and the nodes. You could see all the statistics done over here. Now, pertaining to this project, we believe that the major variable which we need to take in consideration is this right over here, which is the weighted in degree. Now let me explain about this. How does an in degree over here actually happen? Okay, so if you actually take these two, the 10 and 7552 user, so as I told you, it's actually a directed one. So you see over here there's a line, the line which goes from 10 to 7552. That's actually the user 10 buying bitcoins from 7552 and then rating 7552. So that's a direction over here which happens. So theoretically speaking, if any user has a high level of in degree, now that means that that user was the dealer of bitcoins, as in that user dealt with more bitcoins to others, or transacted more bitcoins to others. So that a particular user would have been consulted a lot. So in that sense, that particular user or node in this case would be of importance in the network. Now another thing which we need to take in consideration is that of weights. You could see the weights over here. I have the weighted in degree. If you remember from before, we have actually taken weight into it. So now it actually shows you the weighted in degree, weighted out degree, and all of those sorts. Like if you go over here, you could actually see the weights. Okay, so what in this case we need to find out is that a weighted in degree, because we need to actually check the reviews about what the users gave. So if A transacts from B, we need to actually know how was A's experience, so that rating which A gave is actually translated into the weightage part over here. So in this case, the most important variable which we have to check would be that of the weighted in degree. Now sorting this by a descending order, bam, it gives you user ID 1 has a highest weighted in degree. In this sense means that user ID 1 would probably be the most trusted person in this network, and we would actually be better off by buying Bitcoin from user 1. So that's actually the conclusion of the analysis which we did. Some other things you could actually do is that you could find out, like over here, we are going to nodes, we are going to the colors, we are ranking nodes based on in degree. First, let's just check in degree. Now over here, you look at the in degree. So the red ones would have the highest in degree. I run this and you could see that this one, which is 1, the user 1 which I was talking about in the analysis, that's a user which has the highest in degree. So just by doing an in degree analysis, you might actually feel that all these people, all these users are not actually relevant. But what is happening over here is that we are not actually taking weightage into consideration. So let me just change it to weighted in degree. And now if you look at the difference, you could actually analyze far more other individuals or users which are also trustworthy in the network. So just notice the change in the network. I click on apply and see there are users here, which again are also trustworthy, as trustworthy as 1, but 1 being the best. The only difference was that they might have had a low amount of in degree, but their weightage was pretty consistent and was pretty high. Again, Gephi actually helps us in actually partitioning the whole graph. If you look at again modularity class, and you could see the ones with modularity 4 would be shown in purple, the one with 7 would be in orange. So if you could see, it's an easy way to actually cluster the whole graph. If you can see these points, the ones in orange, those belong to a cluster with modularity 7. So all these components can be easily run in Gephi. Now, just another thing which we like to add on is that the use of Gephi for time series analysis. So again, for this we have actually um, worked on the timeline data. So let that thing load. Yeah, so you could see this as the timeline data. We have actually added the timeline over here, enable timeline. So since this is a lot of nodes and edges, my laptop doesn't actually support for you to see it in the real time. But if you go to data laboratory, you could actually see what we did over here. See, this is the time format. As you can see, I have changed the format and I have uploaded this. So this was a time format, and this is the dynamic column which I made, which is again easy to make. You just go to convert column to dynamic. From here you select the column time, which is this column which we inserted, and then we just have to select the lower limits and the upper limits, and it is done. So what this actually helps us to do is that it actually theoretically, if I play this from start to finish, you could actually see the node 1, in this case the position has changed, it's over here. It would start getting bigger because the number of in degrees happen gradually over time. So you could actually see that change over here. So that's why we actually use time series analysis. There's a few perfections to be done on this, and given a better computer, I'm pretty sure it would have actually worked on this laptop. But it is just for your knowledge, as in how to do time series analysis in Gephi. So that's about the whole video. We hope you guys refer to our PPT to get better pictures and better conclusion on what we have actually done.